Why don't we right away start with a quick round of introductions? Cassie, maybe you want to start?
Oh, yeah, right. There I go, grabbing for a mic. My name is Cassie Kozyrkov. I serve as Chief Decision Scientist for Google. And decision science, decision intelligence is all about applying data science to decision-making, making our data useful.
So Claire Novorol, I'm co-founder and chief medical officer of ADA, which is headquartered here in Berlin. I was a doctor in the NHS in the UK for many years. ADA is a personal health guide, and it's a little bit like an AI-powered doctor. So you chat with ADA about what's bothering you. ADA helps you understand what might be going on and guide you towards the appropriate next steps.
And I'm Rebecca Clyde. I'm the co-founder of Botco.ai. The problem we're solving is helping businesses have more meaningful conversations with their customers. And to do that, we use natural language processing, which is a subset of AI.
I'm Mark Chung. I'm the CEO and co-founder of Verdigris Technologies, which is a energy management company based out of Silicon Valley. We use AI to analyze electric signals and use them to help large critical facilities manage their energy better.
Great. So what I love, we have a lot of different industries. The first question I want to ask Cassie, so how have your views of machine learning changed over the years?
So I encountered machine learning as called that in graduate school. I was in graduate school for mathematical statistics and then pivoted over to mathematical statistics with machine learning and AI. And that perspective, that graduate school perspective, is a research perspective. How do we build general purpose algorithms that we're not going to use to solve any specific real world problems? We're rather going to give tools to others. And it's a very blinkered kind of view there, where you only focus on the development of more algorithms and better algorithms than the ones that exist already. And then leaving academia and going to industry, you start to see the applied side, and you see just how different the applied side of machine learning and AI is. Now you're taking some algorithm that some researchers have made, and you are trying to innovate and solve business problems using that. And it turns out that understanding exactly how that algorithm works inside isn't the most useful thing for the business. Instead, it's thinking through what the problem actually is, thinking through the data, thinking through what you're trying to achieve and build, and how you would know whether what you've made is good enough. So it's a completely different set of skills. So it turns out there's two different disciplines, and we're not calling that out enough. AI is two different things, applied and research.
Yeah, I think there is a little bit of a myth out there right now with all the excitement and hype around AI that the most complex and cutting-edge approaches are the best. You know, they're more investable, and that's the best way to go. Whereas actually, you know, it's all about, are you solving a big problem for lots of people? You know, what's your problem? And then are you choosing the right tools, the right approaches to solve that problem better than other people are solving it? And we work in healthcare. And I think it's so important to always kind of keep that in mind, because so let's take the example of electronic health records. They're hard to get access to. When you get access to them, the data is mostly unstructured. It's full of acronyms, abbreviations, spelling errors, etc. It's quite hard to make sense of that. It's very incomplete. There's lots of gaps. You know, symptoms are not documented, diagnoses are not documented, and so forth. There's a lot of medical error in there, misdiagnoses, tests that shouldn't have been done that were done, or that you know, vice versa. So forget it if you want to use that data to derive best practice. And there's even systematic bias in there. So, for example, in some markets such as Germany and the USA, doctors can bill more if they code for, you know, more serious conditions. So you can imagine there's quite a bit of miscoding going on, and you just can't rely on that. So it's a real problem. So the approach we've taken, well, with what we've built, we simply couldn't have achieved that purely by trying to just pull data from electronic health records and do machine learning on it. You know, we had to take data from many sources, including existing medical knowledge, textbooks, published literature, databases of like prevalence and incidence data and so forth, expert review, a big team of clinicians working with our data scientists and engineers to build this big knowledge base. and a reasoning engine that works with it. It's a probabilistic system. And then on top of that, we build our own data set, structured data set. We're running millions of assessments now. Every 3 seconds, someone somewhere completes an ADA assessment. And we collect data, of course, with each assessment, and we try to close the loop. We try to understand from patients, doctors, what did this turn out to be? Did your symptoms improve? What medication did you take? All these kind of things, and actually kind of close the loop and learn. So we're building our own quality data set on top of this sort of foundation that we've built.
You know, I always think about the first machine learning project that I worked on was very frustrating because I remember that I was trying to solve a very specific problem, but we had to spend so much time preparing the data and organizing it away and throwing out the bad data and working on it for a very small outcome. So it was like lots of investment, very small result. And that was probably about 5 years ago, so it wasn't even that long. And what I'm finding is that that's starting to flip, where the algorithms are getting better. We're starting to have a better understanding of how the data needs to be organized so that we don't have to do so much legwork at the beginning, and we can now start to get more results out of less effort. And that's really what I'm excited about seeing is that kind of ratio starting to change, and that's what's really going to drive a lot more adoption. And for businesses to really look at it as a tool in their tool set, whereas before it was just too daunting. And it was like, oh, I have to hire 1 million data scientists to actually make this work, never mind.
I think you asked about the view of how machine learning has evolved, and when I think about it, I kind of take like a very macroscopic view of it. But I would equate like maybe 10 years ago, there was just a sea of just raw bits and pieces, and because the community is so open source, like a lot of the hardening of algorithms, which were occurring in the university domain and in big companies, became a very open source capability. So a lot of that algorithmic performance and improvement started to happen across the community. And then what you saw is people training off of these systems and building very mature NLP trained sets. And now the problem space is more like the application of these bigger pieces and building on top of it. So I think before everyone was trying to build their own thing, and now as it sort of helped the community because it's open, you see a lot more just the generic problem space's application and not so much the algorithmic performance.
And I want to point out that when this grows out of the research community, the researcher's entire world is to make something more complicated than the one that exists already. So that's why you love the complex methods for their own sake. And that's also why you start with algorithms and you feel the need to rebuild it from scratch, because that's what researchers do. They will rebuild this one from scratch so they can make a better one. But that's not the best thing for actually applying it when you've got tons and tons, libraries and libraries of these things all built. Why would you go and reinvent the wheel yourself?
So how do you choose the right approach?
So the wrong way to go if you want to apply, and the way you'll go if you've spent your whole life as a researcher, is to go algorithms to data to outcomes. And that's the reverse of what you should do. Start with your goals and your outcomes. What are you trying to build? Before you even hire any nerds, before you even get any data, imagine this thing is operational. It's outputting little labels, little decisions, because that's what these systems are all about, effectively. So what is it making for you? And how would you know how good that performance is? And which mistakes are worse than which other mistakes? And how would you score the whole thing? You have to deal with that, with those goals, before you get to the data. And the thing is that if you start with the data instead, you make two kinds of mistakes. Either you lose the business, you completely don't even convince the business stakeholders that they should be trying this applied AI project, or maybe all your business stakeholders are really good at thinking about data, and then you come to a fun other kind of problem, which I've seen a lot working with engineers. You spend 3 hours, 5 hours arguing about whether or not some data input is or is not appropriate for the problem, and you spend 5 hours arguing as to whether or not neural networks will or will not work, and what you've done is subtly, subconsciously, made the whole team agree that we're actually building it. What if it's not worth building in the first place? So that's why you've got to start with those outcomes first, and then you go to data, and then you go to algorithms.
And when you look at data, so what are indicators when you're looking at data sets, choosing certain techniques? I don't know, Claire or Mark, Rebecca?
Yeah, I guess it really, like, I guess what Cassie was saying, I sort of agree. You have, like, you start with your problem, but what data sets and what data you would use to apply to your model to solve your specific problem, I think you need to have an understanding on both sides. This is a roundabout way of answering your question, Mike, but I think it's, if you don't go through the exercise of understanding the solution space and the different approaches to data that you can apply to your problem, you may only apply one lens to solving that problem. And there may be multiple ways to solve that problem that could be much better. A roundabout way of saying that there is really no fixed answer to your question. Like, you have to look at a lot of different pieces.
Yeah, and I would say, I mean, I'm a big proponent of trying a couple of things at the same time and seeing what works best. So, you know, we've done this in our model is, you know, there's a couple of different schools of thought around how NLP works best, right? And again, depending on which academic program, was it coming out of Stanford or Rensselaer, they have different opposing views on how to handle it, but they're both really interesting. So we actually just tried both, like see which one works for the type of data input that we have. And I think that that's the big thing that is hard for organizations. They want us to pick the one sure way and just go forward with that. And you know, we just have to realize that it doesn't always work that way. We have to be willing to try a couple of different things to see which one actually produces the best results with, you know, what you have, and be willing to experiment a little bit.
Do you think that too many founders, for instance, getting a bit carried away by all the new technologies, and again, deep learning is how we have to use deep learning to solve this problem? You know, what do you think is actually, what is simple better? In some cases, I mean, I think we have this tendency of using too complicated methods to solve problems, whilst in some cases it might not even be machine learning that is the best solution to solve the problem, right? Yeah. I know, Claire, like...
Yeah, I think you should choose the simplest method available that solves your problem well. That's certainly the approach we've taken, especially if a complex method won't work, or you don't have the data to be able to use those other approaches.
And I also see startups and big companies approach it differently. You know, I'll see startups, just because we don't have as much money, we tend to look for the simplest solution, and I see big companies sometimes do the exact opposite. They buy the 747 when all they needed was, you know, a motorcycle. Right?
I've got an analogy for this that I use this to drive this point home when I'm training Google engineers. So I show them a picture of a spoon and an oyster fork. And I say, well, this oyster fork, this is the more sophisticated tool, of course. Not that many people know how to use an oyster fork correctly. But look, those who do, when they see you using an oyster fork on your cereal, because that's the thing that looks most sparkly, you look like a fool. You shouldn't be using the oyster fork in the cereal. That's what spoon is for. But then the other mistake is saying, spoon, trusty spoon. I've used spoon my whole life, and I'm just going to keep using spoon no matter what. And then there you are, attempting to apply a spoon to a crab or some oysters, and you know, that's how you lose a whole jacket to that enterprise. And your dinner partner needs a splatter shield. So the right tool for the job. As simple as possible if it works. But if it doesn't work, and for many applications, simple doesn't work, so you must go to complicated, then persisting with simple in the face of it clearly not working is a fool's errand.
There's also, though, a little bit of this comparison going on, right? Especially between founders, like, oh, you know, what you do is really simple, right? I'm using this deep neural networks. Like the, you know, VCs saying, oh, you only have a 100 million fund, I have a 1 billion fund, you know, that's...
You're using spoons on your cereal. Come on, watch me use oyster forks on mine.
Exactly. But I want to talk a bit more about data. So Claire, you mentioned, like, when you started, you looked at all kinds of data sets and you actually found it's the wrong data, right? There wasn't, you actually had to create the data yourself. So
yeah, we did. I mean, in the end, we had to, we wanted Ada to work with the world's most reliable and accurate medical knowledge possible. So it's like we had to take Ada to medical school for several years and train Ada on current medical knowledge, latest knowledge, expert review of that, a little bit like you go and you read the textbooks, you sit in the lecture theatres and listen to the professors and so forth. And then we ran thousands and thousands of cases through Ada, so like gold standard cases. So that's a little bit like going out on the wards as a medical student and practicing, giving it a go, and trained against that. And now Ada's out there and sort of doing millions and millions of assessments. And again, we're trying to close the loop. And what's really interesting is that doctors actually, once they're out there practicing, so when they're no longer at medical school and if they're practicing alone, they very often don't get the feedback to learn from it, especially GPs. Sat in their clinic, they actually often don't learn whether they were right or not. And the typical situation for a GP is that they give it, it's their best opinion, but they often don't know for sure if they're right, and they wait and see if it gets better. There's a textbook for GPs that's called I don't know what it is, but I don't think it's serious. And GPs sort of say that pretty much every consultation, all day, almost everyone. They're not really learning at scale a lot of the time. And that's where Ada is different because, we try to train wherever possible, and we don't always have the data on each case. But yeah, if the data doesn't exist, you have to use what you can get hold of. It sort of does exist, but not necessarily in the format of an electronic health record, maybe in the format of a textbook, and then you build the data set on top of it.
And Rebecca, you mentioned there was before stage actually, they said a lot of cases, the moment you have the data, it's already out of date, right? We talked about this also in the context of leads, for instance. So how did you experience this?
I always talk about looking at your content sources, your data sources very carefully. You may have in there information that's no longer correct, that's outdated, or that simply doesn't represent the type of information you want your company to be expressing. So I always love the example of Microsoft when they launched Tay. And I can use this example because they use it all the time. But they tried to train this bot on Twitter content. And they used Twitter as kind of the data source, which of course we know is like the cesspool of all the worst possible points of view, and good ones too, but really bad ones as well. And so of course within just a short period of time, not even a day, a couple of hours, Tay became this super misogynist, racist, awful chatbot, right? And so it just was a really good lesson to all of us to remember, make sure, don't just assume that the algorithm will select the good stuff and recognize what's good and what's bad. It has no judgment. It makes no judgment on the data unless we have told it to avoid certain things. And even then, it can easily miss them. So be very careful with
and you mentioned the example of resumes, right? As another example of database.
Exactly, yeah, and this is another problem in the VC community and in the hiring world. So if you take, okay, these are the people that we hired in the past and they were successful, so we'll only accept resumes that, represent the past. Well, what if our hiring methods were very biased? What if we were missing really great talent because we were looking at resumes in a way that was inherently already unconsciously biased in its own way? The humans were doing that. And so if you train on past data that's wrong, you're just going to exacerbate the problem. Like you were saying, you're just going to continue to misdiagnose, you're going to continue to mishire, or VCs are going to continue to fund the wrong companies because they're only going to fund in a very homogeneous way because they can't see the variation and the possibilities in other approaches.
Mark, you mentioned before the panel as well, don't use massive data sets if a lot of data cleanup is needed. Can you explain this a bit?
Yeah, it kind of goes down to the same thing that Rebecca was just describing. If you have dirty data and it has all sorts of ways in which you have to kind of unbias that data and clean it up, you are going to have a really, really hard time. It kind of all ties back to the other statement, which is about just choosing the right method, the most pragmatic method. A lot of times you don't have, if you're starting a company out there, and you're like, oh, okay, well, I have this massive data set, let me apply some monolithic way to solve this problem. I would encourage you to rethink that just very carefully and make sure that you're attacking it the most pragmatic method possible. And so I guess what I meant about that is just data cleanup is super hard, and it's very manual, and at some point you'll probably give up before you get a result that you want. So
you also see a trend of like less and less data, right? Previously it was more data. That was the mantra. But actually, I think there's a trend. You now see like smaller data sets being used. I don't know how you guys see it, and also whether that's your experience in respective companies.
Well, to go to this point, it's not actually less and less data used. Excuse me while the statistician climbs out. And, we're high-strung, we statisticians. When there's not much information there, you should not expect to learn much. So how does it work when you attempt transfer learning with less and less data, when you try one-shot learning? What you're doing is you're standing on the shoulders of giants. That's what you're doing. You are taking a model, a recipe, from getting from your inputs to your desired output. You're taking one that exists. That has a lot of data in it, just maybe not yours. And then you're taking that as a starting point to slightly rejigger and readjust that with a few examples from you. That is not using very little data. That is using someone else's lots of data plus a little of yours. And it's really important to see that difference, because if you get the impression that you can actually learn from one example, and there's only one example there, you're one, you are sadly mistaken. That is never going to work.
I guess a way to rephrase it is, I think more and more people realize it's about quality data, right? I mean, quantity is important, obviously, but like realize more and more that quality, rather smaller set, but good quality data is better over a large, data pool that is.
So this becomes highly technical now. So I'm just gonna. We should own the highly technical nature of this. The more complex functionally your model is, the more moving parts in your recipe. That code that's going to go from not the algorithm, the machine learning algorithm, but your final recipe that is then going to live in your systems and take inputs, turn them into outputs. The more moving parts are in that thing, the more little knobs to adjust, the more data you need to make it work. So you need relatively little data if your model is functionally a straight line. But if we are talking about a complex model like a neural network, it can be as high quality as you like. Mathematically, if you don't have enough data, you don't have enough statistical power, you are going to have a horrible problem with essentially memorizing data, not generalizing to the rest of your problem, and when something new comes in, kaboom. And so this is something that it's worth talking about on a technical level rather than on a, well, if you just really go for quality, it's okay, it'll work for any model. That is not true.
Mark, also before the panel, you mentioned like if you have a really hard unsupervised problem, right? Try to turn it into a supervised problem, then crowdsource it.
Yeah. Well, this kind of goes to I think what Cassie is describing is there's another stage of advancement in unsupervised methods that will require massive data sets. And it's not always practical if you're a small startup company. You do want to stand on the shoulder of giants and look at the models that are there, and actually supervised problems that have been human trained that have been crowdsourced, actually best examples of very mature places. And so if you can think of a way to make your problem easier, make it simpler, do the brute force method or do something a bit easier. At some point, this unsupervised huge data set will come over time as data continues to build itself. But if you want to solve your problem today, try and make it a simple one. Yeah.
Rebecca, I mean, you work with NLP. We talked a bit about ambiguity and how to interpret human language and interaction, and how hard that is actually. I mean, that's a problem you're trying to solve essentially. Tell us a bit more.
Yeah, so I always give the example of flying, right? You may have a good experience or a bad experience with an airline, but use the same phrase. You might say, "Thanks, American Airlines," right? Well, you would have to know the context in which I'm saying thanks, because I may be saying thanks for upgrading my seat to first class, or I may be saying thanks American Airlines for delaying my flight and making me miss my conference, or something like that. So the context becomes very important. And then it's the context of what happened before and what state am I in when I express those words, and also what are the cultural underpinning elements there. I mean, I may use different phrases and different words based on the cultural background that I'm operating in, and many of us are in global companies, so we have to be cognizant of that sort of thing. And so there's this whole other layer of just, you can't just take words at face value, because the words may not mean what they say. There could be a totally different intention underneath those words. And so how do you train software, essentially, to understand that nuance? And that part is really hard for companies to deal with. And right now there's a lot of patchwork kind of workarounds in doing that, but I'm really interested in a lot of research happening around emotion AI, emotion databases that are starting to create a knowledge base, essentially, of that type of contextual data that we now need to introduce into our algorithms, and therefore makes them more complex, and therefore requires a lot of examples. Because if I only used examples of German people saying thanks, that would be very different from Americans, or even Southern, US Americans versus Northern versus Californian versus Latin American, right? They would be very different.
So how do we expect technology to figure this out when we as humans don't even fully understand it? I mean, have a very limited understanding, actually, especially if you take cultural differences. It becomes a really, really hard problem. So how do you think that's going to evolve? Do you think that's something we can crack in the near future?
I mean, I'm really excited about kind of the crowdsourcing idea, and this is something where I'm seeing a lot of innovation happening, where rather than expecting one monolith company to be able to solve this huge problem, I think it's going to come with collaboration from across the world. And I'm really excited to see, organizations like yours even, that are bringing together all the brightest minds in AI from around the world to tackle these problems. And I kind of envision a future where AI models are being created in all parts of the world that kind of represent maybe some of their cultural perspectives. And we have a way of almost like crowdsourcing and leasing from each other those solutions, so we can arrive at something that works for whatever problem we're trying to solve. And I think that it's going to require a lot of global collaboration, looking at development work happening everywhere, not just in Europe or in North America, but let's look at stuff happening in India. Let's look at stuff happening in Africa, which is super interesting problems that they're solving there. Let's look at stuff happening in Latin America, and just take a really global point of view.
Claire, I mean, for you, interpretation of data, right, I mean, is crucial. This could mean the difference between life and death. So how do you guys look at it, and how are you trying to solve that?
Yeah, well, it's a little bit like what Cassie was saying with one-shot learning. You have to stand on the shoulders of giants, of decades, even centuries of doctors, creating basically this huge, huge data set, which is medical knowledge. And we're always building on it and learning that we were wrong about certain things. So we have to sort of use this as the starting point and then gather data to build upon that. And then it's this constant sort of readjustment. But you can't just, you can't easily do that. It's difficult very often to get hold of the ground truth in medicine, because it's often doctor's opinion, there's misdiagnosis and so forth. It's great if you have a lab test, absolute sort of hard diagnosis, a pathological sort of pathology specimen or something, but you often, most of the time, in fact, don't have that. So we usually have humans in the loop when we're creating these feedback loops. We don't just allow the system, otherwise you get what the Microsoft bot did. If you train on if you do your adjustments on incorrect diagnoses, then of course you're going to have a pretty good knowledge base that starts sort of going in the wrong direction. So it is a challenge when you're working in a field where you can't easily access high quality data at scale and the ground truth, but we are standing on the shoulders of a lot of doctors over a long period of time who've built up this knowledge base, and then we're working with that and improving upon it.
And if I can add to both of the previous comments, I think it's a mistake that is now, it's a maybe a culturally popular mistake, to think of technology as something independent of the humans. I mean, even in the way that that question was phrased, will technology solve it? No, of course not, because technology is just an extension of us. And there is no such thing as technology independent. Maybe something that looks fully automated, that had all the humans' will and intentions and creativity built in the first place, and now it's just extending, echoing that in the same way as a building crane echoes the wishes of whoever's operating it. But there is always humans in the loop in some way, and you must remember that, otherwise you just expect technology to be magic that solves things that you are responsible for. It doesn't.
And how big is a black box problem here, right? People want to understand what's happening. In many cases, they don't, right? So, I mean, how do you look at that?
Yeah, so when we look at data science, we don't look at data science from the perspective of this algorithm means it's machine learning or AI, and this algorithm means it's statistics, statistical inference, and this one means it's analytics. Instead, we look at it from the point of view of decisions, where decisions are just any actions that any kind of entity might take in their environment. And if you are making no decisions, you are just getting inspired. That's your goal. That's an analytics type goal. And you can use all kinds of different algorithms for that, including neural networks. There's a different goal in machine learning that is about repeated decision making, making a recipe for automating decision making. Statistics is one-off decision under uncertainty. Now, separating those things out and realizing you can use the same algorithm for all of them actually clears up a lot of confusion here. Because if your objective is to get inspired by data, to then work with that inspiration framework to build better, say, medical systems, you are in the analytics realm and you must think about interpretability and you must open the black box. But if your goal is just to make a system that performs the task that you wanted it to perform at least this accuracy, then why do you worry how it works? What you should worry about is, does it perform? And then you must test, does it perform well enough?
So we're running out of time, unfortunately. I want to ask you one last question before we go into QA, which is, in your respective fields, what excites you the most? Also the future, you know, like what excites you? Maybe Mark, maybe start with you.
I kind of tying back to what they're saying. What excites me the most is that you asked a question about if humans can't achieve this, how can machines achieve this? I think what excites me the most is that machines are already surpassing what humans can do on specific tasks and skills. And at some point, I think what excites me the most is capturing human intuition through reinforcement learning into tasks that traditionally we feel we would naturally have to be in the loop on, that we no longer have to be. And that would then free humans up to do many other things. So I would say that's exciting for me.
Rebecca?
Yeah, to me, I come to approach these problems from a humanist standpoint, and I really like the fact that we've evolved from, I felt like we were always having to adjust ourselves to the computers, to the machines. You know, the machines were dictating to us the interface and how we had to accommodate our thinking. And I feel like we're finally flipping that, where the technology is really accommodating itself more to us, so we can continue to be more of ourselves and not have to be constantly adjusting our own way of living to the computers. So I really see AI as being behind all of that and making that possible.
So what excites me the most, I think it's putting more power in the hands of the individual when it comes to understanding and managing their health. More than half the world's population still lacks access to basic healthcare services. And the average time a patient has with a doctor for a consultation in China is 2 minutes. It's just over a minute in India and less than a minute in Bangladesh, you know. So we have a huge shortage of doctors, millions too short, and that shortage is expected to grow, like sort of double in the next 10 years or so. So using technologies like ours to put that information in the hands of the individual, and it will not just be sort of the level of the average human doctor, it's going to be better than the average human doctor. And that's just because no doctor can know it all and remember it all and always be accurate. So that's where we're headed. And then beyond that, even being able to get more and more predictive. So by tracking data over time. So by definition, once you have symptoms, you already have disease, but can we actually sort of track over time and identify things before those symptoms even appear and become more and more predictive? And we will have tools to do that in the future in the hands of everyone wherever they live.
For me, what's really exciting is that all those algorithms, all that hard work of the researchers, and all that data that got logged but no one knew what they were logging it for, and all that computing power, that all those machines that are built and available, those three things are sitting there poised to become so much more useful. This is an opportunity for us to apply the algorithms with the right data, with all that amazing computing power, to get incredible innovations done. So I'm really excited for the future.
Perfect. Like 2 seconds left. Do we have time for one question though? Yeah?
So for the first question, because we talked about machines surpassing humans and we're talking about the next frontier, will an unaltered human be able to keep up in an AI-driven world?
So I want to point out something. There is no one in this room who is better at adding 1 million numbers together than a machine is. So you are already all surpassed by machines, and you have been long before AI. There are things that computers are just better at and have always been, and that hasn't worried anybody. I maintain that actually that surpassing is a really good thing. We want to move that to more domains. What's important, though, is that we ensure that we have actually checked what we're trying to get it to do, and that we've made sure it actually does do that. Not just trust that it's adding the million numbers properly, but have a way to check what it's performing for us. And the code in AI systems is a little more complicated, so we have to be more careful about testing the outcomes, really thinking about the testing.
Actually, maybe can we address the second question, because I think it's a really nice one to wrap up also for startups in the audience. It says, if so many enterprises and companies are already collecting data, how can a small startup find and access data to use it? Rebecca, Claire, Mark.
By asking. You know, a lot of companies are very proprietary, like they might choose to redact some of the actual some of the data itself, but the metadata is still very useful. The findings, the outcomes can still be very useful. And again, this just goes back to what I was talking about. It's going to require a lot more collaboration, and businesses, startups, willing to work with each other to solve some of these big problems versus trying to do it all independently.
I think this is a very good question. Also, one of the probably, in my view, maybe the most dangerous parts of the future, because data is ultimately super valuable, and there are very large companies that have a very big step forward, or advantage in terms of already collecting it. I think that does create some kind of moat for small companies. And my only advice here is try to find your niche, right? Try to find the way that you're going to grab that data. Don't compete head to head. There are companies out there who have a very open attitude towards it, like Google DeepMind. They're very open about their trained models, and they open source everything, so you can find ways to get some of that, but don't try to. I don't know exactly. This is a very tough one.
Synthesized data in some cases.
Yeah, synthetic data.
More governments open up large data sets, so hopefully the trend is going to be positive as well. But I think we have to leave the stage, right, for the next session. So
pretty much. You can have one last comment.
Oh, okay, one last comment.
Last comment?
Last comment.
For us?
Biggest concern.
Last comment. I would then just ask each one of you the question, one piece of advice for the audience to wrap it up.
Start with what decisions you want to make. Sometimes machine learning and AI aren't even what you need. Maybe it's a one-off decision like, should you invest in some other business venture or not? That's not for machine learning. Don't use that tool. Use the right tool.
Yeah, it's repetition a little bit, but identify the problem that you want to solve, and then think very carefully about what's the best approach to solve that problem. Don't get wrapped up in the hype of the latest cool thing.
I think mine is always to just remember that you're always dealing with humans in the other side of the output. So don't get lost in the technology and in the data, and actually remember you're about creating human experience and human connection between your business and your customers, or whatever situation, your patients. It's all about that human experience in the end.
I guess mine would be more abstract, but as humans, maybe the last value we have that AIs won't be able to surpass is the ability to have empathy for one another and learn very quickly. So focus on developing those skills and build on that.
Thank you so much.
Thank you.